Hello and welcome to SudoKanard. We are here to solve this Tableaux Sudoku that was created by Indian author James Peter for the latest Sudoku Grand Prix round, organized by WPF, of course. And so I solved the example puzzle from the instruction booklet a few days ago on the channel, and it was very good practice. So the special rule is that whenever you have such a cage, well, all digits must be different, which in this case means, well, they had to be all different, but for this cage, the usual rules of Sudoku allow digits to repeat. For example, these two digits could be the same, but in this case, they can't, they may not. And you see that this is a cage with 9 digits, so we must have all of the 9 digits in here, and the same happens with this region in the shape of a P, and this one in the shape of a G. That's GP for Grand Prix, obviously. Here you also have such a region, and then some smaller regions with only 3 digits. And the other rule, it's not that they are just extra regions, but also that there must be young tableau, which means that whenever you have two cells next to each other, or not necessarily next to each other, but on the same row, the digits must increase from left to right. And whenever you have digits on the same column, they must increase from top to bottom. So it's like it's as if we had a thermo here and a thermo there and a gapped thermo here, and the same happens here. All right, so I solved it during the contest and I found it pretty difficult. Well, in such a region with all 9 digits, one thing is certain is that the bigger digit must be here and the smaller digit must be there. And it's the same in here, it's the same with this region, except that the biggest digit could be here, could be here. So I just pencil mark it that way. And in this region, something similar is happening. Then we can do some Sudoku logic, meaning that with those ones, we must have a 1 somewhere in here, but because of this, we have a 1 somewhere in here. And with those ones, we also must have a 1 somewhere in here. And then there's something in here. So the 1 should have to be somewhere in here, but this is obviously not a 1 because it has to be lower than that, and digits can't repeat in a cage. So there's a 1 in here, which eliminates this possibility and places the 1 there. And now, in this area, 1 could not be here, but it could be in any of those 3 positions. So that doesn't seem very useful to pencil mark that. In this area, 1 could be in any of those 4 digits. Not useful either. Right, let's have a look at 9s. Well, we have 9s excluded from those, and 9 will be in one of those two. It can't be in the top left because this digit is lower than this one. And in this area, 1 can't be repeated in the region. It can't be here. It can't be here. So we must have a 9 somewhere in there. And we must then have a 9 somewhere in there. And in this, so where's the next place to look? Well, in this area, 9 can be anywhere in here. In this area, 9 can't be into this cell because it must be lower than that. So we still have 3 places for 9, except that this can't be a 9. And the reason for that is that this cell sees both cells here, and we know that one of those two must contain a 9. So 9 is excluded from here. So 9 is only in 2 positions in this area, And we see that now 9 can't be in any of those cells, and it can't be there either because this digit is lower than that. So we get the 9 in here, which eliminates that and places a 9 there. And then 9 is not here, so in this area 9 must be here. And we have a 9 somewhere up there. So that's already a very efficient start. I don't remember being that efficient during the contest, but that's mainly because I had missed the fact that there was such a cage. I had missed the cages in box 3 and 7. When I noticed it, it just unlocked some of the logic. Then let's get back to the bigger cages. We know that in this cage, 2 will have to be in one of 2 positions. Similarly here, 2 will only be here or there, but there's a 2 here, so 2 can only be here. It removes this option and places the 2 down there. In this box, 2 can't be here, so it will have to be here. Now, by Sudoku, with the 2 here, we must have a 2 somewhere there. And it can actually be here with the 1 there. So this cell can only contain 1 or 2. And no, actually 2 here would require both cells here to be 1s. So that wouldn't work. So the 2 is there. Now in this cage, 2 can't be here, so it can only be here. And what I did not take the time to explain is that in those areas, so we know that they are young tableaux, and they contain all 9 digits, so 2 can only be next to the 1. By Sudoku, I get a 2 here. And then in this area, 2 can't go there. So 2 can't go anywhere in here, so that's a 2. And this very area, why did I say very? I'm not sure. I don't know. Oh, well, just by Sudoku, we get the 2 there. And I think we have all of them. Now let's focus perhaps on digit 8. It seems only logical to do that. Or perhaps there's something about digit 1. In this region, 1 can't be here. It can't be here by Sudoku, so it will have to be somewhere here. And somewhere here for this region, I think that's all I can do at this point for digit 2. Now, where is the 3 in this G shape? It can't be anywhere here, so it will have to be there, so it will have to be here because there's nothing to put between 1 and 3. Now, where is the 3 in this region? It won't be here, so it can still be here, it could still be there. And in this cage, the 3 could be here, it could be here. But something interesting is that by Sudoku, we get the 3 somewhere here. And by Sudoku, now 3 must be somewhere here, and because of this 2, 3 can only go there. We can remove this and put a 3 here. I'm being much more efficient than during the contest, I must say. So I think I had missed on some of the intended logic during the contest, and I'm really glad I'm doing the puzzle again for it only for this very reason. So now there must be a 3 somewhere here. If it's at the bottom, then this must be a 1. So this is 1 or 3. Now, where is a logical place to look. I'm seeing this 5, which prevents all of those cells from being 5s. So the 5 in the cage is in one of two places. And the interesting part is that if this is a 5, then where does 4 go? This digit is smaller than all of those, so in this case 4 goes here. And the same happens in reverse. If I put the 5 here, then 4 can only be here. So I think this is a 4-5 pair. And this is now a 6-7-8 triple, but this is smaller than that, so we have 6 or 7 here, 7 or 8 in the remaining digit in here. This 8 is interesting, because 8 in this region must be next to the 9, so it can only be here. So now we have an 8 somewhere here just by Sudoku deductions. On this row, we must have a 4 somewhere. Actually, let's look at the missing digits. Those are 4, 6, 7, 8. 7 is not here. 8 is not here because there would be nothing to put between 8 and 9. So this is 4 or 6. And this must lie between those digits. So it has to be from 5, 6, and 8. Oh, and 8 is not here, 8 is not here. So on the row, 8 can only be here. And I can remove this option. So this is from 4, 6, and 7. So 7 is not in here. That's nothing new. In this box, where is 7? In this cage, I mean, 7 can only be here. So this is lower than 7, it's not a 6, it can only be 4 or 5. This is bigger than this, it can still be 5, 6, or 8. Well, what about this region? It also needs an 8 next to the 9, and because of this, 8 is here. So now, by Sudoku, in this region, 8 is in here. So that's not an 8, and the 8 in the cage must be here, which removes this option and places 8 there. In the column, I still need 4 and 6. And now there's a 4-6 pair, so this is now a 1-5 pair, and this gives us the 4 there, which makes this a 5. Let's recall that this was a 4-5 pair. That's not a 4 anymore. And here we have 5 and 9. So those are from 3, 4, and 6. And we must still have an 8 somewhere in here. So now in this column, 8 can only be here, because of those. Actually, in this box, we still need a 3 somewhere. Here, oh, there's a 6-7 pair here, so this is a 4, and that's a 6, and because this is a 4, in the cage we get the 5 and the 6. Here, those are 3 and 4, necessarily in this order by Sudoku or just by the special rule of Tableaux. This 6 now by Sudoku goes there. And those are 5 and 7, and by the Tableaux rule, they go like this, and it does ambiguate that. We get the 7 on top, places the 9 here. We complete the column with a 4. And this is a 5. So it goes really, really much smoother than I did during the contest. And that's nice. Well, that's the 4. So this is not 7. 7 is the biggest of the remaining digits, so it must be here. Here we have 6 and 5, and by Sudoku they are placed in this order. Now there's no 6 in here, and this with 6 and 7 here, this must be 8. And we have a 6-7 pair in there. This is a 1 just by Sudoku. Here we have 3 and 4, and by Tableaux they are in this order. That's a 4 with 3 and 4 here. And that's 1 and 3. So 1 and 3 places the 1 up there. That's the 3. 3 on the row is here. That's a 6, 7 and 6. And then that's not 8. So 8 here, 9 there, and 4. And 7. Right, so beautifully constructed and really, really not as strugglicious as Super Jambombo would say. Super Jambombo is a YouTuber specialized in some very special games. So I really struggled on this puzzle during the contest, but there was no need to struggle. The clues were really, really tastefully placed. So thanks for watching this video. See you soon on SudoKanard.